I'm back. Hello, hi Lyle. Did you finish your HTML project? You mean, oh man, if you mean my language server for HTML, kinda, in the sense that it's, I released it. I still have some open to do issues, but they are for either relatively fringe stuff or for adding big chunks. Well, the main stuff is there, so I don't consider it finished, properly finished yet. But it's certainly finished enough that you can download it and use it. If you mean my static site generator, that's also usable, but I haven't touched it in a bit. I'm being busy with the rest of the ecosystem. Hello, Penguin. Okay, you know what? Stream countdown is still running, but I think I'm ready to start. Do. Ligma Loba. My brain is fried from making my assembler in C. You wrote an assembler in C? I cannot share your pain because I'm not doing this stuff. I'm doing a language server. So for now, I have this stuff has its own demons that you have to fight against, but different kind of demons, I think. Okay, so I left a nice to-do list for myself here. Hey, X2, hello. So let's continue from where we left off. So we're saying searching self schemas for a schema with the same name. Okay, what do we have in here? Is anything that we have in here meaningful? Let's see. Path schema for Ziggy. I'll print. So we do chop off the file prefix from yeah, when we are given it. Okay. So this is old code. Okay, so this is all old code. None of it has been touched. Have you the rest of the Zig team talked about adding a native GUI building tool within Zig like Raylib and others like it? We haven't talked about that specifically, but I think I can give you an approximated answer based on what I know about the general topic. And the general topic is basically the standard library, right? Because the question is whether the standard library should contain something or not for you to access it. We don't know yet what the standard library of Zig should look like once we reach 1.0. Right now, the main design focus is still the compiler itself, language features, maybe not necessarily features that, you know, connect directly to syntax, but there are a lot of language features that are still that still need to be explored and designed and tried out. The standard library will come eventually, and I mean, it's not like that the standard library is completely it's not a wasteland. The standard library, if you use it now, it has plenty of useful stuff already in it, but it's not well organized, it's not well designed, it's missing, you know, a methodical approach to it. It kind of grows organically. So the question is, should the standard library of Zig, so like, I guess the general question should be, should the Zig standard library be minimalistic or should include other stuff? And then we can decide what this other stuff should look like. I think there is one example that we can definitely consider a limit that we do not want to reach. And that is Python, for example. Python has this idea of a batteries included standard library, which is great. But man, that standard library includes a lot of batteries, and over time, some of those batteries have bit rot. So there's in the Python standard library, there's a few modules that are considered deprecated. So you're told, don't use this, use another third-party alternative. So I would say that's probably, let's consider this the upper limit of how many batteries you can include in a standard library. I think we most probably don't want to go there. I don't know how batteries included the Zig standard library will be. It might be that it is kind of what it is now. It might be that it's a little bit more. It might be that it's a little bit less. Maybe it's a lot more. Maybe it's a lot less. One thing that we do know is that putting stuff in the standard library is how can I say? We need to be careful with how we design this stuff, because you might think that this is purely a technical question, and you might have a preference, right? You might think, well, I think that a language with a slim standard library is good, and I think that a language with batteries included standard library is good. And you know, you can fight it out with people that have the opposite opinion than you. But before it is any of these things, it's a question of money. Whatever you decide to put in the standard library, you need to be sure that you will be able to pay for the maintenance of for the next 20, 30, 40 years. Because if you don't, if you are unable to pay for the maintenance work for that code, no matter what choice you make, like more batteries included, less batteries included, it doesn't matter, because if you're not going to be able to maintain it, then you have nothing. Not only you have nothing, you have worse than nothing, because you have foot guns, you have things that you're not supposed to use because they're deprecated, but then some people will use them anyway. So we definitely, for sure, without a doubt, want to avoid that ending. That to me is the bad ending. You decided, you thought that you could maintain, that you could pay for the maintenance of a given amount of code, and it turns out that you couldn't. And so the infrastructure that you thought you could maintain now starts falling apart. That is the bad ending. That is definitely something we want to avoid. That said, obviously, you know, the only thing, if your goal is to definitely maximize the chances of not failing at that at the cost of everything, at any cost, then, you know, no standard library is the solution. That's also, how can I say, that maybe you don't fail in the same way, but that's also not a happy ending, in my opinion. So we'll need to figure out a balance. Okay, this is the big picture. In general, stuff like Raylib and company, I mean, it's either a matter of us implementing it or providing an interface to somebody else's implementation, right? If it's an interface to somebody else's implementation, like bindings for Raylib, you don't care whether those are in the standard library or not. It really makes close no difference. We have a package manager, like a pretty good package manager, First of all, you don't need bindings to be able to use Raylib. You can use Raylib directly without any Zig abstraction built on top of it. And I think that is a reasonable and for plenty of people the best choice they can make. Then sure, you can write bindings on top of them, and those could be third-party bindings, and there could be varying degrees of competence in how those bindings are made. But even then, I would say bindings are not a big deal. So I think for them to stay in a third-party library, it's perfectly reasonable. As for writing an entire GUI stack that we ship in a standard library, I think that is somewhat unlikely that we make one. I wouldn't say that is entirely out of the question, but I would say it's fairly unlikely. Partially also because of the money thing that I mentioned earlier. I think there are probably, it's better to be spending money and the associated risk on something else, in my opinion. But I don't know. So if I understand what you're saying, and the features like GUI in the standard library may not be the best thing, but building a feature that makes it easier to access the party libraries in the standard. I mean, you already have the second part. Like, it's so trivial. Google how to use Raylib from Zig. It's like, it's very easy. You have to do like fairly little work. So that is already a possibility that you have, and that it's just already there, ready for you. You can do it now. Okay, let's do some work. By the way, I'm happy to continue discussing this stuff. I'm going to do some other stuff in the meantime, but I'm happy to continue the discussion for as long as there are questions. Okay, so we are trying to find a schema for a given Ziggy file. We have here all the old code that was attempting some of these, but wasn't doing a particularly good job because it was just searching for the same name dash schema, which is one thing that we want to do. But it's not, this is not the full story. Also, in check, we have just implemented this whole idea, right? In search.schema. Well, no, we haven't implemented the full idea. We have implemented part of the idea. The problem is that this search.schema right now, as it is implemented, it's kind of tied to so it's using a global variable that's not great for usability, and then it's kind of tied to lifetime management in this context. So the question is, can we disentangle this logic from the specifics of this memory management stuff that we have going on in this piece of in this part of the program, or we can't? Maybe the answer is that sometimes you just can't. There's not a good way, or rather, yeah, sure, you can always abstract those things away. The abstraction can come out like kind of sucky. So, and this is, by the way, okay, I won't rant on this much, but this is something that I find funny. Man, you almost never hear people say, oh, you know what? I tried this as abstraction and it did not pan out. And I'm not talking about like, I'm not talking like abstractions as in coming up with programming language features. I'm talking about like you being a, normal, everyday software engineer, and you're at your job and you kind of come up with an abstraction, and then it does not pan out. You almost never hear people say this because they will I think there's this idea where you kind of cannot fail, right? You just do it at any cost. And so like the thing becomes more and more convoluted and more fucked up, and then it works. And then now, congratulations, you have reused some logic, but then the whole thing has like the super weird control flow. Stuff doesn't seem to make sense because it actually only makes sense if you account for all the possible use cases, like all the possible ways in which the thing is used, and everything is specified because of that. So, so what is my point? My point is that I feel like it is a oh man, look at this. There's also this fucking lock thing, which I could move on the outside. Okay, no, you know what? We're not trying to reuse this logic. We're implementing it. Fuck it. There's way too many things that are like intertwined in it, and I don't know. We just make it sucky just so that we can reuse what is ultimately like a fairly simple idea, right? We have a path, and we keep calling their name on this fucking path so that we can peel the last directory in a loop, and then we keep searching for a .ziggy schema file. So yeah, we can reinvent this stuff. Shouldn't be too hard. Okay, so let's implement this. So this is step number 1. Search in self.schemas for a schema with the same name. Perfect. We have an arena locator with us, so we can take this path. So we can take the file path. This file path is the Ziggy file, and we can turn it into same file name but with -schema at the end. So we're trying to find this schema. We try to do get. Oh, there's get and then a or else that does a put no clobber. Oh man, look at this shitty code that I wrote. By the way, this is another very funny thing. So this is shitty because we're trying to do a get in a hash map, and then on failure, we do so if we don't find the element, then we do a put. But if you do a get and a put separately, guess what? You are basically going through the hashing process twice. And we have a way of avoiding having to do this twice in Zig. By the way, I wrote this code, so I'm just complaining in my own code. And it's called get or put. And that is such a awesome API. There's almost no reason to use anything that is. You either do get or you do get or put if you plan to put something in there, almost always. So goop self.docs. Wait, is this docs? No, it's schemas. I split files into docs and schemas. Let's see, I'm into my second week learning Zig from PHP. Nice, it's been very enjoyable so far. Cool. Yeah, enjoy the ride. Remember that it's like PHP is a fairly self-contained ecosystem. So you're now opening yourself to, all the things that you can do with a programming language, and that means that you have to worry more closely about what it is, how the OS works, how linking works, static libraries, dynamic libraries, shared libraries. Well, I mean, those are the same thing. You don't need to learn this stuff day one, but be aware that there is a universe of new things that you never had really the chance to manipulate directly in PHP. I'm guessing with PHP you were exposed to maybe some of them somewhat, because I'm guessing you can. I think I remember this idea that you can load like dynamic libraries in PHP so that you can call C functions. Actually, you can certainly do that because I believe that's how ImageMagick works. I think it's a C library with PHP bindings, but yeah. Okay, self-schemas, get or put. Get or put, and what is the key? So we need the allocator. The allocator is self.gpa, and we need the key. Oh, this is going to be interesting. So we need the key, and the key is going to be path. And if found existing, gop.found existing, well then success, we found it. So I guess we can just return that. Also, this is a uppercase schema thing. What the fuck is the schema? Oh, I guess we can, so that's going to be the value. So we can just return the value. So return gop.value ptr.star. But this is going to get nuanced now. What if it's not existing? It is not there. We are adding it. Well, if we are adding it, there's an interesting problem. Okay, I'm gonna see if anybody in chat knows this. I will reveal what the problem is if nobody figures it out in a few minutes. But can anybody see what it is that I'm doing that is horribly wrong so far and horribly problematic? You should be able. These lines are enough to tell you that I'm doing something horribly wrong here. Or rather, it's not, what I'm doing is not categorically wrong, but in practice, it kind of is. Ownership of path. Correct. Or rather, it's not entirely a matter of ownership, but it's a matter of, I'm using two different allocators for it. So whatever, and the fact is, like, the allocator, like, it intertwines. So I think your point is correct. I'm just being nitpicky about it so that for the benefit of other people watching. So ownership of a piece of memory is not the same exact concept as which allocator it is that you used for it. But the two things intertwine. Specifically in this case, we want the hash map of all schemas that are loaded in the language server to be long-lived, while this arena exists for only within the context of one request. I haven't shown the full logic, but the idea is, maybe I can do that. Well, you know what? I won't show it, but we'll explain it briefly. The idea is LSP, the LSP client, so the user's editor has notified us that a new Ziggy document, not a schema, but a document, so think of it as a JSON document, just a different file format, has been opened. And we know that we have some ideas, we have some conventions on how to pair a document with a schema document that defines its schema, so that we can provide users with diagnostics and auto-completion and go to definition. So for example, this is a Ziggy document. In here, you can see that we are complaining, schema mismatch, expected bytes found int, and we can go to definition. We can go to definition, and it sends me to the schema document, which has the same, in this case, has the same name. One is test.ziggy, the other one is test.ziggy-schema. So this is the feature that powers this kind of stuff. So what is the problem? The problem is that we are in the so the client has notified that this has happened, and so we are processing this notification from the client, and we will have to reply something back to the client at some point. But we have this arena that is a allocator that is scoped to this request. So it will be reset as soon as we're done processing this request. So it's an allocator that is very useful for temporary allocations. But if we want something to survive the end of this request, we cannot use it, because this is an allocator that it's a scratch pad that you can use for temporary allocations, but anything that needs to survive for longer. And in this case, we have a hash map where we open files and we save them. That is stuff that needs to survive the request. And so we cannot use the arena for that. But now we have this conundrum, because here's where it gets delicious. We don't want to allocate path on the main allocator, because we don't know yet if this thing is going to be, we're going to find anything or not. Or rather, of course we could do that. But the optimal thing is to keep using the scratch pad as much as we can, because this thing, is going to be useless if we don't find the corresponding file. So we need to deal with that. And the funny thing is that you can do that in Zig. It totally works. It's kind of part of the plan of how the interface works. So here we did get or put using this heap allocated, this arena allocated path. If we do get a match, it doesn't matter, because if get succeeds, if we did find an existing match, this is just doing it's hashing and then doing a comparison of the bytes here, but then it doesn't store any of this. It doesn't store this value. So this is good. This is fine. The problem is, if found existing is false, then we have right now path set as the key pointer value, and we need to fix that. So we can do it right away. It's very easy, actually. All we have to do is gop.key key ptr dot star equals try self.gpa self the gpa.dupe path. We basically set the key to the new value. I don't know if I did everything perfectly correctly programming wise. There might be some minor programming error, something minor that I got wrong. I'll fix it later, syntax wise. But this is the idea. The idea is that you still get a chance to move the key to a correctly heap allocated value. So now with this, we have fixed the mismatch that was happening before. The path can be yanked from the hash map. Yes. The hash map will retain. Well, I guess it depends on how you implement the hash map, right? A hash map could be implemented in a variety of ways. But these hash maps basically have, I think this is an array hash map even. No, this is not an array hash map. But that being said, it does keep around a pointer to its keys, because hashing helps you navigate through the data structure faster, right? But then there's an actual comparison to check that the key truly matches. So to do with this, we fix the key. Now we have the hash map with a key in it. Also, look at what we can do. So we can do this. We can duplicate the path. We could even free it from the arena, honestly. Also, oh no, you know what? I take this back. So now that I think about it, you know why I didn't do get or put? Is because I am not confident, I'm not optimistic that I will find this file. You know what? My old code was not that wrong. I take it back. I did a get separate from a put, because I was really not sure that I would find the file, because it is true that right now, I don't know if I will find the file. So what we could do is that if we optimistically do the get or put, and then we remove this entry if we don't find the file. But to be honest, I think this is in practice, this is going to be kind of an edge case. I think that it's not going to happen often that a file has the same file dash schema next to it. I think that the main use case for people will be use dot Ziggy schema files that apply to all Ziggy files in a given subtree. So I think I take back the bad things that I said about my code, my past code, and I will mirror the old logic. So if we mirror the old logic, it's interesting because then this whole thing will be less confusing because it's basically this same code. You know what? We can just straight up reuse this old code then. So instead of files, this is going to be self.schemas. Try to get the path. If there is path result, awesome. If there isn't, we open, I'm going to call this source. So we do SDFS, CWD. We have to fix, oh no, this was already fixed. Okay. We open this file, we read it all, catch return null. This we do need to fix. So this catch return null was kind of optimistic. Oh, you know what? Actually, so because the file, if it's file not found, then great. But if it's something else, you know what? Let's do it like this, just to make it nice. Switch error dot file not found. Return null. Oh wait, previously we're returning null. Now we cannot return null. Right, because we have the other fallback option. Okay, I'll need to fix this control flow in a sec though. Else, let's do it like this. Else, log.info or error. Log.error. Do we have log? Yeah, we do. Log.error, unable to open as a Ziggy schema for T. So unable to open path has a Ziggy schema for URI for reason error. Okay, so just so that we log this in the LSP, and then we do I don't know, return null. This is wrong, but we're gonna need to fix it. In any case, schema loaded, blah blah blah. So we make a Ziggy schema. There's error defers, but we don't really care about error defers in this case, honestly. If this is an error, if this is an error, we attempt it. Whatever. You know what? We can do it, so let's do it. Okay, here's the duplication that was happening. So this is where we, in the old version of the code, we're taking path from the scratch pad and copy it into the main allocator and do the put no clobber. And then we would return schema. Interesting that I decided to do this inside of a or else. If result is Ziggy schema, return result of Ziggy schema. All right, because in the old version, we had one hash map for everything. So this would be, this could very well be a return. Okay, but this is the old control flow. So we need to update this to the new control flow. The new control flow is you try to find it, and if it fails, so this needs to be a series of if else. So if, I think, so if schema, return schema, else try to open the file, try to add it, and then return it. But this might not go. This might not go well because there might be either a file not found or something else. So in here we actually want to do the same thing in both cases. So here's what I'm gonna do. I'm gonna add a block for file not found. We do nothing. For this guy, we just do the print. So we can also remove this then. Nice. Actually, you know what? I think I prefer this. Yeah, I think I prefer this style. And then here we do break BLK, and that's it. And BLK goes here. Sorry, BLK. Okay, so here basically we have, if we find schema, great. Otherwise, we go through this other procedure, and there is a label so we can break from this block. If we break from this block, then we just don't continue down here, and we'll find ourselves down here. And that allows us to continue with the algorithm. So if none is found, try to open it and add it as a non-open schema file. I guess point 2 was here, basically. And then if not found, try again with the dot schema. Okay, so to do, you know what? I'll remove these things, and they were just for reminding me. It's kind of obvious what we're doing. No need else after if return. No need else after if return. No need else after if return. Where do you see if return? The only thing that is close to an if return is this here, but you definitely need an else in case it is not found. Okay. So here we need the dot search. We can do this dot Ziggy schema search. If it's not found, it returns anyway. No. You see this break? This break is designed to not enter here. This is important. If we don't find the file, we exit this block early. We don't compute this. We get down here and we do Ziggy schema search. So I think that I can copy paste some logic now from here, because I'm not abstracting this code, so might as well just copy some of it. So how does this work? I think we want kind of this. If it's found. If it is found, if the file succeeds and it is found, I don't see any else down here. Sorry, I don't know what you're referring to. So we need to start from a path that we can modify. It should be this guy. You know what? Const path, const bar path, and you know what? Leave it const. It's fine. So path there starts from path. We assert this assert is not necessary in this case. So we know that it's going to be the path as the same file, just dash schema. We call their name on it. And then we do the gop stuff. Oh, woo. Oof. Oof. This is a big thing that I forgot about. So, this is a big thing that I forgot about. Inside of check, I was doing this thing where every time we would attempt to go up one level, we would write down if a given directory had nothing, so that we could see that and skip checking basically every level of the directory every single time, like forever and ever. But you know what? I think in this case it's fine to not have this optimization. Yeah, I think it's fine. So this is why I was doing get or put, because we were putting something there no matter what. But in this case, we want to stick with the get separate from put approach, I think. So we have the path directory. Then what were we doing? We were making it a path that had Ziggy schema at the end on the arena. Then still on the arena. Then we were trying to open the thing, search for errors. Okay, so this can also pretty much be the same. So schema source, refile alloc options. We do try to read on self.gpa. Oh, right. We don't fatal in this case. We just log whenever we have errors trying to access schemas. Okay, so that's fine. Catch So this part is actually this. Actually, no, this is just schema. Okay, so we do schema source. Does this do any error printing, etc.? No. Okay, we don't do any error printing in here as well either, I guess. So we just make it. Okay, and now we have to put this stuff in the hash map. So let's see what was check doing. I was just gulping it out. Okay. So in our case, by the way, so it turns out that trying to abstract this thing made no sense because we are also using a slightly different strategy. In the other one, we were not saving the .ziggy schema part. We are not saving the full schema path. We were only saving in the hash map directory paths. While here, we cannot do that, or rather, we don't want to do that. We want to instead save the file with this full path. So yeah, completely different approach. Very, very interesting thing. So here we make path schema and we say what do we say? We say try self.schemas.put no clobber allocator self.gpa key is gonna be try self.gpa.dupe path schema and the value, which is schema. We do this and then we just return schema. Okay. If this does not work, because at some point we do instead of or else return missing schema, we can do or else return null. Okay. So this is actually it. But there's also a third parameter, open. So here open is false. Okay, this is almost right. Almost right. What we're missing is that after we do the path schema, we do this. If self.schemas.get schema return the schema. And only if we fail to return this, we care about freeing it. This is nice. Okay. This should be the thing. This should be the thing implemented. In theory. So we either return a schema or we return. But so far, the only error that we can return is out of memory. So let's put that in stone. Let's see if I'm right. Document is not marked pub. Okay, so there's more of this refactoring that I'm doing that has issues. So let's just quickly take a look at where we found it. This is just ooming. Here, I think we're returning more errors, right? Because this is load file. Actually, I don't know how this stuff is handled. Anyway, okay, let's see what the next problem is. Document is not public. Document is not public. Okay, LSP44. Logic the document, logic the schema. Oh, because it's not logic dot, it's just documenting schema. Okay. So what's in logic? Load file. Okay. Next problem. No field name files. Yeah. Okay, so there's more of LSP.zig that we need to fix. 255. Definition. So uh you know what I fear the problem is here? I bet you they were not being told what the language type is. We're just getting the URI. So by having two different hash maps, we're kind of cursing ourselves here. That sucks. Okay. This sucks. Oh, for Ziggy schema, I don't have any support for for definitions. Well, this is easy then. Okay. So this is like self.docs. And we don't switch anything. That's it. Just search in docs. Okay. Is it the same for both maps? Yeah, it's basically a file path. And I used to have one hash map that contained both schemas and Ziggy documents, and now I split that into two different hash maps. One has they're both string hash maps. Well, this one is a string array hash map. This one is not, but that's a minor thing. The main thing is that this one contains documents, and this one contains schemas, but they are conceptually pretty much the same thing. Like one is its source, it's an AST, although this one is a schema AST, while this one is a language server AST, which is a fancy way of saying just Ziggy document AST. The other main difference is that a document points at the path, has a path to a schema, to the schema, the currently active schema for it, while schemas do not. But schemas have the concept of being either open or not, because I'm going to put in that hash map both documents that were opened by the client and documents that were not. And they have the concept of a number of references, which, by the way, I need to now wire in. Right now, I'm not using these values properly. Because a schema might not be opened as a document, but it might be referenced by three different Ziggy documents. And so we want to keep it in there as long as those documents are open. And then when they're closed, we want to clean up also the schema as well, because we don't need it anymore at that point. I mean, we don't have to, but I think it's not too complicated of a feature to have, and it, reclaims some memory so that you don't have like a ever-growing hash map forever. Okay. Let's keep fixing compile errors until we're done with those. Definition. Oh, right. I didn't fix all of definition, right? Because I regressed it. So now we need to change it. So I grab the document. I grab the offset. Previously I was doing the schema. Now it's different. Now it's more like if self.schemas dot get dot the schema. Let me see. Yeah, document schema path. If it's present, oh, without an if. So just, yeah, try to get it, or else return null. Actually, this could even go here. So immediately, document, we need to find the document, we need to find its schema. Then we compute it, the offset. Although, you know, this basically cuts off completely go to definition in Ziggy schemas, but I guess it's not critical and we can re-implement it later. Actually, we never implemented it, so we can add that later. Not super important. So node IDX resolve the offset. So okay. If node is 0, return null. Otherwise, grab the node and return that stuff. URI. No. URI is none of this stuff. URI is doc.schema path. There we go. This is actually pretty delightful. This is a delightful change. No need for the arena, really? This guy doesn't need an allocator? It does not. Oh man, that is so cool. Okay. So we fix this. What do we fix next? 257. Oh, what is the problem? Right. This is also or else return null. Actually, the or else return null goes in there because if schema's path is there, then if this value is set, it needs to find stuff in the hash map. Like if the value in the hash map is missing, then we have a programming error. So we don't hide it, we make it a crash so that we can get a chance of fixing it. 277. Dot schema path dot question mark. There we go. Or you know what? Let's do it like this. Const schema path doc dot schema path or else return null. Remove it from here and make this less shitty. There we go. Nice improvement. 293. Okay, what's the next problem? Hover. I'm guessing same logic. Yeah, we don't have shit for Ziggy schema, so we default to doing this for docs. Cut this off. Cut this off. Do the schema stuff immediately. Const schema path. Not schema. Or else return null. Nope. Const schema self dot schemas dot get schema path dot question mark. Okay. Then we compute the offset node index like before. And here there is some stuff going on, but I don't think we need to touch any of it. So, okay, so this should be it. Load file. Okay, 130. Load file expects something else. Oh, yeah. CVN expected 3 arguments, found 2. Right. So load file is implicitly opening a schema that is open. If out of memory when creating the schema after the doc, I don't know if I handled it correctly, but like, I think honestly in this case, I think we should just crash. Because, I mean, I guess we can return an error to the client. I don't know. It's just that I think that in the context of a language server, even if we somehow survive and report the error, nothing good is going to happen. That is my suspicion. I dripped some tea. Sorry, I need to get a piece of paper. I'll be right back. Okay, I'm back. Docs and schemas are necessarily in sync, returning an error. Would better continue unreachable. An optimized build assumes that unreachable is never taken, correct? Yes, correct. Yeah, correct. But I do think that. So let's see what's happening in here. In here, we're trying to load a Ziggy schema. If something goes wrong, we unload it, but then we do return the error. But then how is this error handled at the call site? So in like did open, we try. So you know, trying from here that trips a panic handler. So long story short, I'm not doing a spectacular job at expressing error control flow. Like in my CLI tool, like here in the implementation of check, I'm being very precise with the control flow that results from me passing errors versus catch-zooming immediately. Although I'm not perfect either, because I think I should do like a full audit. That said, I think in the case of the LSP, it's kind of fine for now. If we let the error bubble up, we'll panic. So this RDFR is kind of superfluous. The reality is that the moment that we return an error from load file, we bubble it up to the LSP handler, and that's a panic. And I think it's fine. I mean, sure, it could be nice to try to make this, bulletproof. I do have this strong feeling, though, that even if we do that, we have not really gained much at the in terms of user experience. I think that this whole LSP ecosystem is, I don't know, it is what it is. So nothing much to gain by striving for more, in my opinion. Okay, 169. So here we make a schema. In schema for Ziggy, right. So every time we make a schema for Ziggy, the answer is that it's false. It's never open. That is not open. This is not open. But it is open if you're trying to load a Ziggy schema directly. Yeah. Okay, so this is where we're doing correctly. What's the next problem? Logic 173. 173. Files put no clobber. Oh. Schemas. No field name Ziggy schema, instruct LSP schema. 176. Right, because I split them apart. They're not a union anymore. Next, logic 184. Expected type U8 found const U8. Excuse me? Oh, I see. Since the type of path is slice of U8s, non-const, like a mutable slice of U8s, then that's the type that path there was inheriting, and then it was incompatible with their name. Next problem, incompatible types U8 and void 195. What is going on here? Oh, that if final fund is continue. Okay, so this is the problem from before. We want this control flow for both cases, and we're doing a poor job at it. Continue. If I didn't want to print this log error message, everything would be nicer, but I do want that. Expected the arguments found 1, 205. Right, it wants U8 as the first argument. LSP 150. Okay, did change. So this is another handler that we haven't fixed yet. So let's see. New text. Okay. Yeah, you know what? Fucking incremental reloads. So document did change. We get. Oh, we assert. But then why do we have file? Load file URI file tag. We pass file as the last argument of load file. This is weird. This is not like this anymore. Yeah, file what? Oh. 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 Huh. That was a neat trick. Fuck, that was a neat trick. Fuck, that was a neat trick. Fuck. Okay. So basically, this did change can happen for both a schema or a document. And we don't know which it is yet. So we can do it like this. We try it right now. Since we don't have this language type information anymore, we just try. And I don't know, we hope that everything goes for the we hope for the best. Self dot docs dot get notification dot text document dot URI, sorry. And oh, that is also interesting. Here we're trying to do get on the URI itself. We're not slicing it. That is interesting. In logic, when we try to grab a schema for Ziggy, in path we were removing file blah blah. I changed this code, but were we somehow putting it back? Oh no, I remember. The way it worked is that we were nesting the schema. When opened this way, we would nest the schema inside of the document. So that's why we didn't have to worry about it. Well, fuck. Well, fuck. This still does not answer how this was working. What the heck? Because I do load file. We passed it in the full URI, right? Yeah, we were passing in the full URI. So we do get or put the full URI in both cases. Okay, so here's what I learned. I learned that I have to also have this prefix in the hash map. We can't ignore it. We cannot skip it. So this is not URI blah blah blah. This is just URI. Let's call this doc URI. We call this schema URI. And then we don't do this, but we do schema URI. We skip the file part when opening. Um, Start from schema URI, which is this one. Okay, we just need to be careful when we open files. That's it. So here we do the same logic. Path schema. Oh, you know what? Yeah. URI doc. URI schema. And this can be, this instead of path there is, oh, can we pass this thing through their name? No, we can't. Fuck. We cannot do that. We have to do this here. We have to skip this part here. Path there. Also, this needs to be path there. Wait, what the heck was he doing in check? Oh no. That is bad. Man, that was such a bad bug. I was basically not peeling path there. Well, like there was a clear bug there. Hello, hello. Okay, so yeah, we do their name on path there. So this is truly is a path schema, but then we don't dupe. We need to alloc print. So basically we place back, so we move this stuff to the right allocator, but we also need to give it back the prefix. Yeah, otherwise none of this stuff is gonna work. Okay. Okay, so now let's go back here and we say, okay, if we find it in docs, then we do stuff inside of doc. And if we find in schema, schemas, then great also, like either one or the other. And let's see what we're doing here. We don't need to do this. This can even be a has. I think we have has. Okay, the signature is completely different. Self, arena, new text. Self, arena, new text. URI and then language. Okay, never mind. It's not all that different. Oh, this actually can be done inside out. So like this. There we go. Okay, it's kind of weird to read, but it works. So we try to call load file, and for for the last argument, we say if we have URI, do we put a comment here? It's better, yeah. For the last argument, we say, okay, do we have URI? Then do we have something in docs? Then it's Ziggy. Do we have something in schema? Then it's Ziggy schema. Then otherwise we return null. Okay, and we don't do anything. Yeah, these are the first stuff is kind of weird. I should remove it. It's misleading. It's making you think that there's like some path to recovery. But you know what? Maybe I'm wrong and there is. I don't remember. Okay. Is this the correct way in the new version? std in fd. I mean, I would say that this is not correct. Well, okay. I don't know, maybe it is, but I would say it's definitely not idiomatic in either the new or the old version. So here's how you do it. If by new version you mean, you know, an unstable build of Zig, like a 0.16 dev build of Zig, then you do it like this. You do io dot file dot std out and stdr, std error. And what else did you want? You wanted std in? Yeah. And std in. That's it. This is std.io.file. 0.15.2. Okay. 0.15.2 is std fs dot no, std.io dot get std out. Maybe the O is lowercase. Does anybody remember? No, I think it's uppercase. But it's std. You know what? Maybe no, it's lowercase. Okay, this is how you do it. I don't remember the casing of the first letter. No, you know what? I think it is uppercase. I think that's how it is. So this is 0.15.2. This is 0.16. How do you recommend getting started in Zig? It's not member error showing. Okay, so here's how you learn about this stuff. zigline.org, version 0.15.2, standard library documentation. Oh, never mind. I forgot that there was an intermediate step. So in 0.15.2 is fs file std out. So X2 knew this stuff and I didn't. So never mind. This is too old. This is not 15.2. This is older than that. So 15.2 is, instead of IO, is std.fs.file. std in, std out, stdr. So yeah. So how do you recommend starting with Zig? Go to the official website. Learn section. Take a look at the language reference. You don't need to know it by heart, but you should scroll it all once. Then, obviously, you need to have Zig installed in your system, and you need to be able to use it. If you have an editor that supports language servers, you want to install ZLS. You want to install, syntax and lighting for Zig, so you need to get some developer tooling. Shouldn't be too complicated though. And then what I recommend is taking a look at online learning resources. There's a book made by a member of the community. There's Zig.guide, which is a website that contains information on how to do stuff in Zig. There's Ziglinks. Actually, Ziglinks is probably one of the best ways of getting started if you want a easy learning curve. It's basically a repository that contains a bunch of programs with mistakes in them, but the program tells you the comments tell you how to fix them. So for example, this is the first one. This is hello world, but it tells you that there's something wrong with this code. You read the comment, you learn what it is wrong, you fix it, and you can run Ziglings in a shell, and it tells you, okay, you fix this error. Now the next one, exercise 2 is now broken, etc. And you continue with that. One more issue I'm facing with NeoVim, some type error not showing, typing like bool cast int, but error showing on build. Yeah, you can have that work, but it requires you to have a proper build set up. So you need to have a project that has a Zig build, and then take a look at this. You want this. I personally keep this setting on. They recommend you do the other one, which is perfectly reasonable. I personally have this on, I believe. Actually, don't remember specifically, but in any case, so this should answer your question. Okay, so we fixed this load file stuff. What's the next problem? No final function named has. Right, I was saying has. What is a boolean get? Contains? I mean, I can do get, but I thought there was something better than get. Contains. God damn it. Contains. Yeah. Constains. Let's see. Cash Wasabi. Hey, Christoph, is async IO already available in the SLib on master? It is, yes. It's not all there. There are, for example, the event loop implementation on macOS is missing some implementations. So some IO stuff is to do. But the thread pool implementation on macOS, I believe, has everything in it or close to. So you can definitely start playing with it. If you have a complicated project that you want to move to IO, there is a non-zero chance that you might hit a to-do. But it is, to give an example, I already moved my Redis client to it, and it works. That said, the Redis client is only using, networking. So my point is, I don't know, if you have a complicated project, you might not be ready to just port all of it. If you have a simple project, chances are that you can port it. If you just want to play around with it, being able to do async and you want to write a small, one-off CLI thing just to try it out, that totally works. Yes. Oh, we can't return now? Oh, we just returned. Never mind. No field name files in Start LSP 170. Did close. Right. You know what? Let's do it like this. Okay, we do a fetch remove. If we find the key value, blah, blah, blah. And then we do the same for schemas. Okay, what's the problem? No member function name function move in array hash map. Oh shit, you can fetch remove from hash map, or you cannot fetch remove from array hash map. That makes sense. Because it has to be like a swap remove, right? So this needs to be a swap remove. But is it also a fetch? No, fuck. Is there a swap fetch remove? Fetch swap remove. There we go. Expected mutable document found a const document. But we actually do not care. Okay. LSP line 50. Dinit. Right. This part doesn't. We don't even really care. But yeah. Okay. There's no value iterator in array hash map unmanaged. You know what? We don't care for now. Let's just leak everything. Who cares? Oh, we built. Okay. Let's see. Cool. Yeah, I have a game engine / framework that has different tick rates for my systems, rendering collision game AI. Okay. Two things come to mind. One is that is definitely the kind of project that I would recommend being not going all in yet with. You will hit A to do potentially. So I would say you can cautiously start inching towards. You know what? You can make a branch and you can start trying to port the framework if you want, but it is possible that you will hit a blocker, and I don't know, do so only if you're not doing any, gigantic refactoring so that instantly bit rots your entire branch. So if you're not doing that, then try this stuff in a branch. Otherwise, wait a little bit more. I can tell you also more specifically. Let's wait. Probably you will want to wait for Andrew to come back. He's traveling right now, so he's gonna be at a Zig Day in Japan on 4 days from now, and I think he's gonna come back a few days after. So I would say December is probably gonna be a good time to get the ball rolling with this stuff, because will also be Andrew that will be able to readily merge fixes in case that you hit something silly that you know how to fix, or in any case you will see more progress happening there. Second point is be careful because with async IO, because what you describe is real time, and providing real time guarantees is explicitly a non-goal of async IO. I would even argue that async IO is the polar opposite of real time. So, or like async in general. So I would caution against using async for something like a game engine where you can aim for more precise synchrony between the various components of your system. I'll give you a simplified example because I've never made a game engine, so I cannot speak from first-hand experience for this specific use case. But there's a even simpler use case where I can speak from experience. Zine, my static site generator, is basically like a silly compiler. It's a toy compiler. It compiles Markdown to HTML. So it has a fairly precise, it has a very well understood and static pipeline. Read Markdown files, process their front matter, then process their content, then process in parallel process HTML templates. Then once both these stages have completed, then now we can start evaluating templates and Markdown files. We can evaluate the HTML template in the context of each Markdown file, which produces a given output. And if we are installing this output in a directory, then we also do that. So the pipeline is very precise. I'm not going to port that. I am not going to port that to async IO because there is no point. The pipeline is so well structured that the properties that I get from async IO are not what I need, or rather, I need to look more into it into detail, but I might benefit from, for example, non-blocking IO. So maybe I might benefit from some of this stuff, but the general, how can I say? But going all in with async IO, I think is going to be a non-goal for Zine. There are parts of Zine where async IO will definitely be beneficial, tremendously so. But I don't think that the main pipeline would gain anything from going to async. I would actually lose something, in my opinion. Counterpoint to that, a web server where you have different clients that come in at different times. Like, my point is that another way of looking at it is that, in Zine, everything is predictable, very predictable. And so you can optimize for that, right? Because you can structure the pipeline accordingly. But a web server instead is chaos. You have a bunch of clients that connect independently from one another, and then they do requests that could vary in nature significantly. One client could request a database search that requires, like a couple seconds to fulfill. Another request could be very easy. Another one could hit like your Redis cache. I don't know. So they're all very different in nature. And so what you want is to be kind of elastic. You want to make your system more elastic. You want easy syntax to adapt the runtime behavior of your program to kind of do a best effort thing. I don't know if that is what you want out of your game engine. So don't take my words as don't stop me from experimenting. Sorry, don't let me stop you from experimenting. That's what I wanted to say. That said, do be aware that async is not designed to give you real-time guarantees ever. It's designed to give you best effort liveness. So stuff tries to move forward the best it can, and depending on the specific implementation, it will juggle things differently. So if you use io.threaded, you will have multiple threads that do the juggling. So DOS does the juggling at that point. You can have a grid and threads implementation where instead it's our runtime, our scheduling that does the juggling, but you still get some juggling. But it is best effort. So for example, even cancellation does not guarantee you that stuff gets canceled, that the cancellation succeeds, and then the cancellation will really happen. There will be code that maybe you implement yourself, that maybe it's implemented by somebody else, where canceling just doesn't work. Like doing cancel does nothing. So the thing will still proceed to completion, even if you call cancel it. So that's the problem space that async solves mainly. And I don't know, that to me, as an external observer, does not seem to be super compatible with what you want out of a game engine. Maybe, question mark. You will be able to do this evaluation better than I can, since you're doing this work firsthand. But my point is, if you see that async gives you something, and then you say, "Oh, maybe if only async gave me like this real-time guarantee," no, it won't. It cannot. I think it's basically asking for it's asking for something wrong. That said, that's an opinion. That's a design opinion, a design of how to design async. So my opinion is just one opinion. So don't take it as the ultimate truth. That said, I am participating in the design of async, and I do have the strong impression that async is really antithetical to any real-time thing. And so if Zig wants to provide the real-time guarantees, I think will have to be something different. Language feature, I don't know, something is not library, whatever it's going to be, I don't think it's going to be async. Maybe there will be some interaction with async in the future, I don't know, but real-time should not come out of async. That's my impression. Okay, sorry, very long rant to say something simple, but it is what it is. We need to do reference counting for our schemas. We are not doing it yet, so let's go do that next. Okay, is hover implemented correctly? Yeah, we did fix it earlier, right? Yep. Formatting also. Why are we not getting anything about this? Is this typoed? Is it not formatting? Is it just format? Because this code is completely wrong, right? Self.files doesn't exist anymore. So this thing is not being analyzed. And I bet you that it's because we fucked up this thing. So we never wired this in reality. It's kind of funny. In any case, we need to worry about reference counting first. So what interacts with that? Did open, did change, and did close interact with that. So did open, we get a language ID, and then we do load file for that file with that given language ID. If it is a Ziggy schema, so let's take a look here that we do everything correctly here. So we make a Ziggy schema. We might have found it existing. So if that is the case, we de-init what we had before. The reason is that it might have been updated in the meantime. Like this is an open. Chances are that it is the same, but it is not guaranteed. So let's make sure that we reanalyze it, etc. So if we had that thing open, we de-init it. We set to everything to the new source, the new AST. We probably need to free the old stuff. And here we are doing the init on the AST, but we're not freeing the old source. So we should also do that. It's self.gpa.free gop.value ptr.source. So we free the old source, put in the new source, put in the new AST, and that's it. Regardless, we set open to true. Okay, so this doesn't even matter much because we do set it to true from this code path. If the thing existed and had some reference counting attached to it, we don't lose that. Just set it to true. Okay, Ziggy. When we open Ziggy, we do schema for Ziggy, blah, blah, blah. Okay, so for now, I'm going to leave this here. Let's look at did close now. So did close. So for docs, yeah, we can definitely swap remove. But for schemas, we can't fetch remove because we need to see what the referencing counting status is before we can really remove it. I mean, we can fetch remove and then put it back, I guess, but that's silly. So we don't do this. Let's do get PTR. Is there a get? So we get pointer. And we say if schema dot open Well, does it even matter? It doesn't matter. Schema.open equals false. And then we say, I think it's kind of like this. Okay. If schema.refs greater than 0, we set schema open to false, and then we return. But if schema refs is 0, then yeah, we kill it. Which is a fetch remove thing. Const kv equals kx, kv equals this. This is just a fetch remove. We free kv.key, we free, we call the init on the schema. Also, you know what I'm noticing? That this is kind of dumb. Why are we not freeing source in here? That's the right place. Same with schema. Also, I'm calling it doc still. GPA.free, not dot source. Yeah. Okay, that means that wherever I did this extra, it makes no sense to do it anymore because it's the init does that. So yes, so this is fine. This is fine. This is fine. Okay, let's go indeed open. Okay, so it's load file where we don't do this anymore. Okay, so yeah, back to LSP, did close. So if it's a document, we're happy to kill it. Actually, no, we're not happy to kill it. We have to do some work here as well. If it is a schema and it has refs, then we just set open to false in return. Otherwise, we remove it for real. Okay. If we want to close a document, then we also have to do this. If well, we have to do this basically. We have to get the corresponding schemas. So it's like this. If kv.value dot schema path if there is a schema path, we grab the corresponding schema. This is not even an if. This has to be there. We grab the corresponding schema. We decrement refs. And then we say that if refs is 0 and schema and it's not open, then we free it. Shadow capture from outer scope. Oh. Yeah. decrease the number of references. If there are no references and it's not open, then free it. Okay. So this all makes sense to me. Then what do we want to do afterwards? So closing is taken care of. Opening is not fully taken care of because also the change is fine. The change I think is fine. Did open is yeah, it's the only place where we need to do some remaining fixing. Oh man, this is gonna be gnarly. Okay, load file. So here's how it works. If we have opened so if we open let's do the Ziggy document first. If we open a Ziggy document, we do schema for Ziggy, and schema for Ziggy should create a schema that has a ref set to 1. Yeah, schema refs should be set to 1 when we do it this way. But if we do find it, oh, this is interesting. If we do find it, then we also need to do the same. Schema refs. So we need to do get pointer. We need to add to its refs. And same down here. There we go. So if we do find an existing one, we want to increase this. Okay, so this part is fine. So here's the gnarly part. The gnarly part is we opened a new Ziggy schema. Opening a new Ziggy schema might might change what is the Ziggy schema that applies to certain Ziggy documents. So the question is, for example, if this Ziggy schema is foo.ziggy schema, then we need to see if there is a foo.ziggy schema also in documents. And if there is, we need to change the active Ziggy schema for that document to the new one. And we actually should even produce new diagnostics for it. Alternatively, if it is a .ziggy schema, then we need to look at all the Ziggy schemas that have a path that matches, basically. And thankfully, we can do it with a prefix. Like we can basically just test that the prefix matches. And if it does, then we need to set these. Actually, no, checking the prefix matches is not enough. Fuck. We need to do some work. Yeah, as I said, this is the gnarly part. Let's put it this way. We don't have to implement everything at once. So let's see if what we have works. And then once this works, we can move to the new stuff. So what is your problem? Oh, dot question mark. Man, I was so optimistic that I didn't introduce horrible errors in like the 2 changes that I made, but never mind, I totally did everywhere. So what is your problem? Is this optional? Fetch, what's your problem with fetch remove? Oh, this is the what? Fetch swap remove. No, wait, this is the fetch remove. It's schemas though. Oh man, that would have been a annoying bug. Optional type, blah blah blah. So this is still a dot question mark. Let's see. Oh, this is also a schemas. This is also another shitty error. Holy shit. Okay, we did build. Now watch it horribly poop itself. This works. This works. Okay, this all works. Holy shit, this did work. What did I do originally that returned an error? Oh, I tried to open a empty file, and he complains that we're missing the root file expression type expression, which is actually fair. That's a reasonable complaint. Okay, let's get into bench. Let's see if we pick up the .ziggy file. I think we do. Language server exited. No, never mind. Oh, okay. We're starting to see the problems. So exit. Do. Okay, what's the problem? Rich and reachable code. Trying to find schema at file user Christoph Ziggy bench who.ziggy schema. Right. And that makes us rich and reachable code. Put assume capacity no clobber. Put no clobber context. Put no clobber. Okay, 211. Put no clobber fails. Oh, yeah, it definitely does. Holy shit, am I dumb? Okay, let's see what horrible things have I done. Okay. So the problem is we try to find it using path schema, but path schema it's a path join arena. Oh, Jesus Christ. So we need to do it like this. Path URI. I think there's also join FMT. It's FMT join. Yeah. Okay, fnt join. So we print path URI. Like this. So we alloc print the path URI, and then we do const. This should be path schema. No, this should be URI schema, I guess. Path schema is URI schema. Hello. Okay. Because we need this freaking thing right away. I don't think the problem is that we cannot pass this to their name. We have to exclude this from their name, but we have to do this every single time. We have to do this every single time. Sorry, this is not S, this is F. Okay, so URI schema. Shadows what? Oh, this URI schema. There we go, URI.schema. Does anyone know about a good logging library for Zig? Yes. Check this out, std.log. It's in the standard library. Take a look at how it works. It's a pretty decent logging system. You can personalize where the log goes. You can create scoped loggers, and yeah, it's pretty versatile. Doesn't do everything. I don't know. You need structure logging to a cloud thingy. Okay, maybe not. Or rather, you can maybe kind of make it work, but then it might not be optimal. But for stuff that is slightly less complicated than that, std.log really helps you a lot. Oops. Okay, so we look at this. Okay, and this is not an analog print. This can be just go back to a dupe. But this is okay. I think we can give better names to these things then. There we go. Ba-da-ba-bum. Okay. How are we doing in terms of building? Consider omitting try. Fair point. Slice of non-array type. Expected arguments found 1. Okay. It's not pretty slash extendable like printing timestamps. It is extendable. I mean, if you don't like how it looks like out of the box, fair. But it is definitely extendable. I'll give you an example. Okay, so this is my CLI tool for the Ziggy data language. Think of it as it's a JSON alternative, and I have CLI tools, and then I have LSP. So these are like, FMT normal CLI tools, and then the LSP is the particular one because you're launching it as an LSP. So standard input and standard output starts getting used to communicate with an editor. So what do we do here? Let's see, main function, decide the IO implementation. Then we set up logging, which I'm gonna skip for now. And then we say, if the command is LSP, we set LSP mode to true, which is a global variable. Okay, this has to do with how I print stack traces, so never mind. But let's take a look at logging.setup. So in logging.setup, I set up login to a file, put in a cache, in .cache for the user. But most importantly, here I have log function. And this is my logging function where I can personalize how the logging printing looks like. So if I want to put timestamps in here, I can do that. So this is where basically you can do all the stuff. And if you look at std.log, it tells you. Actually, does it tell you? It should tell you one way or another somewhere. Oh, wait. They have colors now. So when I copied that function and made my own implementation, we didn't have colors, I think, and now we do. That's cool. Options, logfn. Yeah, so basically these options is the stuff that you can override from your main file. From your root file, sorry. To do here std options, you can see that I specify that logfn is logging.logfn. So if you have this in your root file, then you can provide your own function and you can make it print whatever you want. Okay. Zig build. Zig build. Restart. Go to definition, no definition found. Okay, it seems that we're failing to find a we're failing to find the dot file for foo.ziggy. So we need some log printing that tells us what went wrong. So guess no, this has to stay. We want to look at logic, and we want to basically add some debug printing for schema for Ziggy. Trying to find schema at. Also, you know what we can do? Talking about logging, we can do this. We can basically temporarily mute everything else. This stuff should be done in a better way, but for now this is fine, I guess. Okay, so validating schema, sending 94 errors, trying to find the schema at foo Ziggy schema, which does not exist, right? Oh, every single file should be Ziggy except a .ziggy schema. Right. Okay, so if we do try to find this file, it says validating schema. Wait a second. So we do succeed. Oh, you know what we failed to do? We failed to set the schema path. That's what we're failing to do. Okay, I think it might be that we're doing everything right, except we're missing just a tiny little bit of integration, which is we cannot just give the schema. We need to pass the path, the schema path, and the schema. So it's URI schema, common schema path, except, man, this is a problem because here I would be returning bytes inside arena, and that is bad. We don't want to do that. We do not want to do that. So here we want to, and we can't copy those either. We need something that better than get pointer. We need something that gives us a key value. We need get entry. Get entry. Which I think we can call KV. While ptr.refs. And then we return kv.key ptr.star. And then kv. Oh my god, I keep typoing this. There we go. So this is it. And we kind of need the same down below. So here, get entry. Okay. On success, on creation, there we go. And down here, it's pretty much the same down here, just has a different name. So this needs to there we go. Okay, so with this, we are returning always both schema and schema URI when we succeed. So this is not just maybe schema. Oh, no, wait, this is maybe schema. Man, why do we have this weirdo type all typed out here? It's just making noise. Also, I need to take a look at this logic because it's sus. So we are trying to collect diagnostics for the document. Right. This whole logic is bogus. What's the song that's playing? It's 100-minute electron swing, vocal mix, upbeat jazz, and energetic dance background. That's what's playing in the background. It's not bad. I've listened to much worse completions of this kind. This one is, eh. Okay, this whole logic is shitty. I never implemented good logic for this stuff. We need to take this to the next level. So we found a document. Awesome. We did find a document. Fantastic. Fantastic. Then schema for Ziggy. So the way this should work is that we either find a schema for Ziggy or we have the default schema implicitly, basically. And here we need to validation errors. Yeah, and here we need to call validate on the default schema if we don't find any. We have to do it. I'm actually surprised that what we have right now is yeah, no, this is just shitty logic. Okay. We can do it. This only returns out of memory. Fine. So here's how it works. This is try schema for Ziggy, or else either we find a schema for Ziggy or we have the default schema. So let's do this first. Oh, I see. I'm waiting because I need to collect also validation errors so that I can stuff everything into a single slice of diagnostics. Okay, I get why this is the way it is. Okay, so this is basically, this is it. The only difference is that we are missing. Okay, so we return validation error. So we're kind of just missing the else branch. Okay, so this could have been worse. This is not too bad. So take this, put it here because it doesn't need to be to live anywhere else. Const schema URI const schema equals ms. So we unpack everything like this. Then we say if the schema has errors, we break with nothing. Otherwise, we validate it. That's fine. Else, we kind of do the same with the default schema. So it becomes Ziggy. It becomes break blk with try ziggy.schema.ast. Is this schema AST? Validate default. Okay. Okay. So this all works then down here, but we're missing wiring in this stuff. So in this case, we want to do this. We want to basically take the document and assign it to the schema. Well, what if it's not null? Oh, you know also what we're missing? We're missing the case where the document already has a schema. It's okay. We can also add that. So let's say that here we assert Actually, we don't. I don't think we need to assert any. Doesn't hurt. Gop value ptr dot schema path is null. Okay. Schema URI, blah, blah, blah. This should be renamed also from schema path to schema URI. Okay. To have the schema URI, we set it. Okay. So this is all well and good. Okay, so this needs to become an else if. So the first if is gov.value ptr dot schema URI. In which case we do const schema equals self.schemas.get schema URI. Okay, so if the document already has an associated schema, use that one. Otherwise, try to find one and assign it to it and use that one. Otherwise, validate default. And this is still not perfect, but at least we're inching forward towards the right resolution. Better than it was before, that's for sure. There is only one last thing that I think we need to worry about, and we're kind of good then. So the only thing that we need to worry about is this key pointer stuff. So if found existing, the init what was there before, assign new source and assign new AST. If instead it was not present, then we duplicate the URI. Okay, so this is correct. So this seems good. Let's see if we build. Right, there are some changes that we need to save because I renamed stuff, but the file did not get saved. So logic. Right. This is the a dot question mark. What? Missing struct field start in schema AST. Missing struct field and struct declared here. How is it that we're hitting this only now? What? Oh, we're not wiring in default source and default AST, huh? There you go. Okay, we built. So far, so good. Go to definition. That is correct. It got us to .ziggy schema. Yes. It did work. Wait a second. And if I do... But is this applying the right schema? Oh, right. The problem is that this is an anything, so... Also, interestingly, this does not get recognized as a Ziggy schema file by Helix. What the heck is going on? I don't have syntax highlighting. Text. Why don't we recognize it? That surprises me. Hello, Diablo. Actually, bar is int. So this does not load the schema immediately because this is not recognized as a schema. So the LSP feature is not working. But now this is working. So schema mismatch expected info on bool. So we are loading the right schema. Yeah. Why is a nameless .ziggy schema file not being recognized? This is a Helix configuration thing. It's on me. Roots, injection records, file types. Oh, it's Ziggy schema. Scope, text.ziggy schema. I guess this is source.ziggy schema. This has been dropped. This is it. Injection and file types. So this is the file extension. So why does it not like this then? This should be enough. It just does not. I don't know. What the heck? That is weirding me out a lot. That is weirding me out a lot. I don't know. This is like this is a Helix thing. How do we make it recognize dot files? I really think that this has something to do with the fact that it's just a dot file. Helix file type dot file. I don't know. Hiding. Yeah, good luck. No, okay, let's go to Helix, to the docs, the documentation. Do languages. Scope. A string like source.js that identify the language. Currently, we strive to match scope name used by popular text-based grammars. File types. File types of the language. Example, YAML YAML. See file type detection section below. Oh, roots is also interesting. A set of marker files to look for when trying to find the workspace root. For example, cargo lock, yarn lock. This might be a good feature because right now I'm doing this search myself, but this might be a good feature. This might be what we want. Auto format, estimate comment tokens, block comment tokens, indent, language servers, grammar, formatter, soft wrap, rulers, text width, path completion. File type detection and the file types key. Let's see. Helix determines which language configuration to use based on the file types key from the above section is a list of strings or tables. For example, toml, glob makefile, glob.gitconfig, glob GitHub workflows star.yaml. When determining a language configuration to use, Helix searches the file types with the following priorities. Glob. Values in glob tables are checked against the full path of the given file. Globs are standard Unix style path globs. Okay, extension. If there are no glob matches, any file types string that matches the file extension of a given file wins. Oh, I think I understand the point. The reason is that since the file starts with a dot, that's not a nameless file with a Ziggy schema extension. That is a file whose name starts with a dot, and that it is extensionless. We need these, or whatever the correct syntax for this stuff is. Equal sign. Okay. There we go. Now it works. So now I can do. Oh, I can open Ziggy foo.ziggy. I can go to definition, and it works, and it does get recognized. Now I can change this document. So here's what we're missing. Right now, changing this document does not recompute diagnostics to any of the corresponding files. Maybe we want to have some kind of, I don't know, reverse index that maps a schema to the documents that use it. For now, let's do a linear scan. So the way it works is this. The way it works is in LSP, the change so we're loading a schema, and the idea is if the schema was found existing, it means that we're using it. So we can do it like this. If gop value ptr dot refs greater than 0 to do add an index. Yes. We do this for basically we want to iterate on all the open Ziggy documents, and we want to check if any of them depends on this schema. And schema.ast.errors.len is 0. Then we want to do this for self.docs.entries. I guess we can do it like this. .keys. Actually, do we care about keys? Oh yeah, we definitely do care about keys. Okay, for each one of these bad boys, we kind of want to do this basically. No, I want to do the validation error stuff. So if v, maybe we should rename v to doc. If doc.ast.errors.len is 0, so if it doesn't have syntax errors, or you know what, if it's different than 0, we continue. Const validation errors equals oh wait, so we need if it has errors, we continue. If doc.ast const schema URI is doc.schema URI, or else continue. If doc.schema URI .ptr is different, then gop.value ptr .kpr gop.kptr, yeah. .star.ptr. Okay. Sorry, if it's different, we continue. Okay, so if we're down here, then everything matches. And so we should kind of reset those error messages, but I guess that's what happens when we send this stuff out, I guess. Okay, validation errors is schema.validate schema.validate. Come on, why am I not getting any help? Well, it's arena, and then doc.ast, doc.source. Also, schema source is schema dot source. Oh, because it's schema.ast. Is this it? Oh, okay. It's CLS not working. Fine. To do. Ooh, do we init the eggs? No, we don't. No, we don't. Oh, wait a second. Can I even do this? Wait a second. Because here, what are we doing with this stuff? Okay, we were doing this. Okay. Yeah. We do write notification. Yeah. Okay. Okay, so control flow is a little bit more complicated than it was before. I'm gonna fix this in a second. So we do this. I think we can free this stuff. So you know what? I'll assume that I can. Okay. And for validation errors and diagnostics, we do fmt alloc print. Oh shit, we're doing also this. That sucks. That means that these frees are not gonna work. That is sad. That is sad, but I guess such is life. Although technically we could save memory. Yeah, you know what? Here's how we do it. Uh critical capacity, critical memory use of this arena. This will not include the storage required for external keeping. Yeah. Reset. Map precise free. Critical capacity. I think wait, we're missing something. Where's the oh, there we go. Is reset retain with limit. Um Requested capacity. No, I feel like we're missing one thing. Resize is not pub. I think we're missing one piece of functionality. Anyway, it's fine. No needs. I guess we can leave it to do. Would be nice to be able to snapshot the arena and reset it to this point. Actually, wait a second. Why don't we fully reset the arena? Why do we even care? Do we have anything useful in it? We have schema that works off of GPA. We have everything that works off of GPA. You know what? There's actually nothing that stop us from resetting the arena at this point. The only problem is this guy, which might live in the arena. We don't know if it does or not. It probably does. This guy probably lives in the arena. Huh. But in here, we don't need to use it. We only need to use it in this other case. Okay, resetting the arena might be problematic at this point in time, so let's not do it. I need to fix my code though and make it better. Okay. So we do this, we set everything as we should. I think this should be fine. So this all works. Okay. So here it's a Ziggy schema, but we are doing this for the doc URI. There we go. For each document, we do this. Yeah, you know what? I think that we can get rid of this. I think that we can get it, pull it off. Okay, the diagnostics are these guys. So if we do have diagnostics to send, we do send them this way. And I really think we can reset that thing. Okay, why do we care about schema URI? Oh, because it's this. Okay. So if the document doesn't have its own errors, if it does have a corresponding schema, and if the schema that it has is our schema, is ourselves, then we run validate again on it, produce some diagnostics, and we send them out for this document. And then we proceed to the next document until we scanned all documents. We can definitely reset the arena here in the middle. We can do a beautiful reset capacity, because also we're entering this case, so we're definitely not entering the other case. That said, we need to count also for the case where the schema does have errors, in which case we will do this. You know what? Maybe this should be moved above. Something like this. If errors is greater than 0, then there's this whole thing. Well, that ends with a return. And here, more than testing for this property, we assert it. Okay, and then we copy this here. And this doesn't have to be URI. This can be, well, let me think. Yeah, this can be URI if we want. So first we send diagnostics for this thing, and then we start resetting the arena is fine. Okay. Okay, the only thing that is unhappy now is the other code path. Where we can do this. There you go. And we return for good measure. I think this is much better than what we had before. I don't know if it's correct, but expected type U size. Yeah. Error union type, blah, blah, blah. Try. Okay, we built. Restart. So far, so good. Bool. Undeclared identifier. Bool is definitely not an undeclared identifier. Also, this does not complain anymore, but wait a second. What do you mean the undeclared identifier? Bro. Okay, restarting makes it work again. Undeclared identifier. There's something sus going on. Definitely something sus going on. Okay. Definitely something sus going on. This validate here. Am I misusing it? No. So that part seems fine. Huh. So it's this that's causing us to return an error. If schema AST errors land greater than 0, so this somehow is causing these problems. How the hell do we end up with undeclared identifier? How? Oh no. Oh, okay. You know what is going on? Except the infant bull. Okay, so there's something sus about these diagnostics. But if I make this a bool, then this doesn't complain anymore. Oh, this is nice. And if I do buzz, Schema mismatch, missing field buzz, schema mismatch, unknown field. Okay, so we are correctly. We are correctly recomputing this stuff. Where is this error coming from? Okay, there is a silly mistake somewhere. It's nothing too terrible. What I find interesting is that here we have a return. So the fact that here we have return means that when we load a Ziggy schema, yeah, I'm a little bit confused. So I think the Ziggy document case is fine. What the heck? And this is not me resetting the arena at a bad moment because I haven't added that yet. So, huh. Also, the fact that it's saying unexpected identifier, undeclared identifier, what do you mean? It's Boolean. Undeclared identifier. Oh, so this does get recognized. Undeclared identifier. Okay, this is a fascinating. It's a truly fascinating piece of of misbehavior that really surprises me. Did I do something silly like misconfigure what LSP should be active for a dot Ziggy schema? But nah, not really. Oh, nice. This is also, so this is applying. So schema mismatch, unknown field, unknown field, unknown field, unknown field. So this is complaining about everything except the first buzz, because if we go to definition, then this is correct. Let's say that this is bool, and now complains that there's a schema mismatch. Expected bool found something else. Also interesting that it stops here instead of continuing to validate the rest. It should not stop validating the rest, I think. So that's another thing that we need to fix. But we have these like live update functionality now. Just some kinks to iron out, I guess. I think I'm gonna stop here the stream. We made a bunch of progress. We don't have everything. We clearly have some bugs that we shouldn't have, but now our language server does nicely, not perfectly, but it does nicely live update. It does reevaluate documents whenever whenever we change the schema, which I think is cool. Yeah. So I don't know. I'll fix these errors, and then this is going to be another piece of functionality that we have implemented. So list is for publishing Ziggy is growing shorter. I mean, it grew longer because I also remember that we need to update the website as well. We need new docs. But we are close to being done with this polish pass on the LSP. So, not bad. I still don't know how the heck I'm getting this problem. I know you keep saying that you only rate Zig streamers, but you'll never convert people to Zig if you don't rate non-Zig streamers. Which non-Zig streamer do you think I should raid? The thing is that at this point, I'm usually kind of lazy. I'm not raiding T-Soding. The guy has, I don't know. He did it all himself, but the guy has issues with Zig, so we would not be doing him a favor by raiding him. Cakes, it has C++, right? I think he tried Zig at some point, and then he had an overall bad experience because, well, he wanted a bunch of stuff that he used to from C++, and none of it was there with Zig. Some of it because, Zig doesn't want to have it in the first place. Some of it is because early days, and so, some of the things that he did not like about the experience were definitely missing pieces in the Zig ecosystem. So, you know what? I think it's fine. The thing is, I'm lazy. I don't want to go in chat and have to interact with people. Well, not because I'm lazy. It's because I'm tired. I feel like it's deserved laziness. So I'm gonna stop here for now. But in the future we'll raid more people. We'll see. Thank you for watching. And Johnny's live. Wait, really? Why does he not have a Zig tag? Oh my god, Johnny. Thank you for pointing it out. Let's raid Johnny. He's in there. Go tell him that he needs to add a Zig tag to his stream so that I can find him. Me and all the people interested in Zig. So thank you for hanging out. See you guys next time.